Today's lesson is about sign diagrams. So this class we're just going to learn what they are and practice using them and setting up and drawing them. The next lesson we'll use sign diagrams to solve our quadratic inequalities in one variable. So that's it. We learn it today, we use it once, and that's all we use it for in grade 11 pre-cal. Grade 12 pre-cal, we do a lot of graphing. You could use sign diagrams in grade 12 pre-cal to graph, but we will use other methods. But if you go into calculus, sign diagrams are used a lot in calculus. The calculus class we have right now at this school, they are in the curve sketching unit. So every single class, they are drawing multiple sign diagrams per question per day. So they are used heavily in calculus. So if you think you're using calculus in the future, this is a very, very important lesson. Keep your notes from this so when you go into calculus, you can refer back about how to use, draw, and interpret sign diagrams. Okay, so the good news is you don't have to actually graph for these. A sign diagram is just a diagram that tells you the sign. It's pretty literal, right? So what are the two signs? Signs are positive or negative. So it tells us where an expression, or it'll be a function in the future, where they are positive or negative. You can get that information without having to graph. So it saves us a lot of time and gives us some key information about our functions or expressions. So today we're just dealing with expressions. The next class we'll be looking at them in inequalities. So I'm going to go through the steps. Just bear with me. First time through, it's just going to be a whole bunch of words that probably don't make sense. So we're going to read through it together. I'll try to explain it, and then we're going to do one example together. And when we do the example together, then I think the steps will kind of make more sense. And then you have a worksheet today. Oh, I think there's about 10 different questions. It's not hard, but like I said, once you do a couple, then it's like, oh, okay, reread the notes. Okay, that makes sense. But let's just go through. I'll try and explain the words first without having the example, and hopefully it makes sense. So step number one, we're going to factor or simplify. I had a little bit. The language I had in your notes is express the expression as a series of linear and irreducible quadratics. That's a fancy term for just saying factor. So if it's already factored, you're good to go. But if not, you have to look first, can you factor, simplify your expression or equation first? Then once it's in factored or simplified form, then you're going to look for key points. Now what are key points? Key points are going to be any values that make your numerator and or your denominator equal to 0. So that should be pretty easy for us to do right now. So step number one, factor. From the factored form, look for key points. Those key points are any values that make your numerator or denominator 0. Then you plot those key points on a number line. So we're not actually graphing on graph paper, you just need a number line. Then here's the fun part. Okay, steps 4, 5, 6 are the fun part. Then you start with a large X. Now, what do I mean by a large X? So a large X is any value larger than your largest key point. And I'll explain that again when we run through the example. So any number larger than your largest key point. But we like to use big numbers like 1,000 or 1,000,000 because it just makes it sound a little bit more fun in math. But any number larger than your largest key point you can use. And then you run that value through your expression. Now the good news is we don't have to actually calculate. We don't have to figure out what the value is. We don't need to know the number, we just need to know the sign. When you run that large X through the expression, will it make the expression positive or negative? So you don't need the actual number, just the sign, because it's called a sign diagram. We're not actually graphing, just getting the sign diagram. So if you run it through, it'll either make the expression positive or negative. So then you go and put that information on your sign diagram. Now this is the only one you have to test. You only have to test one value first. You start with your largest, any large X larger than your largest key point to get that information. And then to get the rest of the signs, we just have a little pattern that we use. You don't have to run and test every single value through. After you've had your first one, then you're going to move to the left to the next key point. Now, the rule is you don't have to plug that number in and see if it makes it positive or negative again. Just use the rule. If your key point comes from an odd power, not whether this number is odd or even, but whether the power that it's to when it's in its bracket is odd or even. So if it comes from an odd power, you're going to change the sign from the previous region. And if it came from an even power, it's going to stay the same. So you only have to test one number, then you just go from right to left, looking to see odd or even, does it change or stay the same? And then you continue through all the key points. So it's not as bad as it may sound. Like I said, it's new language, new terminology, but once you do a couple, really easy. Today's lesson, you're just going to practice making, interpreting, and reading them, and then tomorrow we will use them. And like I said, if you think you're going to be in calculus 2 years down the road, save these notes because you need to come into calculus knowing how to do sign diagrams because they come up a lot. Okay, we're going to do one example together as a class. So first step, can you simplify, reduce, factor? Nope, I've already given this one to you in simplified, or it's already factored form, so that's good. So you didn't have to simplify it, but on your worksheet, you will have to check first. If you can factor, factor that first. Okay, then the second step is look for our key points. How many key points are we going to have? Well, we're going to have 4 key points. What value of x would make this term 0? Well, that would be -1. -1 plus 1 is 0. What's our key point from this bracket? Well, that would be 3. 3 minus 3 is 0. What's our key point from this bracket? That would be -4. -4 plus 4 is 0. And what's our key point here? Well, that would be +5. So kind of similar to when we got our non-permissible, so that should be pretty straightforward. So what values make the numerator and or denominator 0? Those are your key points. Now we're on step 3. We're plotting on a number line. Again, we're not graphing a number line. So we don't need to have it to scale, just as long as we have it in the correct order. That would be -4, -1, 3, 5. Okay, here's the fun part. Now we're into steps 4, 5, 6. We start with a large key point. So our largest key point is 5. So any number greater than 5 we can use. We can use 6, 7, 5.1, 1,000, a million, a billion. We like to say things like a million and a billion just because it makes it sound more fun. But any number larger than your largest key point. And again, we don't have to calculate. We just have to figure out, if I take any number larger than 5, will it make this expression positive or negative? I don't care about the number, just the sign. Okay, so let's use a billion just to make it fun, because a billion is greater than 5. A billion plus 1. I don't care what the answer is. Is that positive or negative? Well, that's positive. A billion plus 1 would be positive. A billion minus 3 and then square it, well, that also would be positive. A billion plus 4, well, that's positive. A billion minus 5, that's positive. Again, I don't have to actually get the numbers. I'm not graphing. I just want the signs. Okay, now if we run it through, our numerator, we have a positive number times a positive number. A positive times a positive is positive. In the denominator, we have 2 positive numbers as well. A positive times a positive is positive. Then, again, we're just pretending that we ran a billion through. We don't need the values. We're just looking to see what sign it would make it. We have a positive number on the numerator and a positive number in the denominator. A positive divided by a positive is positive. So basically, if you run a billion through, that makes that entire expression positive. So I'm going to put a plus sign there. So if you've got extra time in quarantine, test it out. Any number greater than 5 will always make this expression positive. Test it out. Okay, now the good news is we don't have to test a number from each region. We're just going to use the rules that we had. So we go from the right to the left. The first key point we hit is 5. Now let's see, where did 5 come from? This is where 5 come from. Now it's not whether 5 is odd or even, it's the exponent outside of the bracket that we look at. When there's no number there, we know that that's a 1. So 1 is odd, so the rule is if it's odd, you change the sign. So that means if you take any number between 3 to 5 and run it through, that will now make the expression negative. Like I said, if you're bored in quarantine, test it out. But we don't have to, we can just use the rules. Okay, now I'm going from right to left. The next key point hit is 3. Let's see, where does the 3 come from? Here. Now, it's not whether 3 is odd or even, it's the exponent outside of the bracket. Well, that is from a power of 2. 2 is even, so according to the rule, the sign stays the same in that region. Okay, now we keep moving to the left. The next key point I hit is -1. -1 came from here. There's no exponent on the outside, but we know if there's not, there's 1. 1 is odd, so we change the sign. Then the next key point we hit is -4. That came from here. It's not whether the 4 is odd or even, it's the exponent outside of the bracket, which is another 1, and it's odd. So that's our sign diagram. So it's kind of messy here, but this is all we're doing today. Next class, we're going to use this sign diagram to get our answer, but for today, if we just learned how to set it up and plot it and interpret it, that would be great. Okay, then I just have some notes at the bottom of your notes. So what does this mean? Because this is weird. We've never seen anything like this. What do all these plus minus means? Well, any region that's positive means that that's where the expression is going to be greater than 0. So the expression will be greater than 0 in this region and in this region. So test it out. Any number from -4 to -1, when you run it through, will make that expression positive. Any number between 5 and infinity, if you run it through, will make that expression positive. Any region with a negative sign, we have 3 regions that are negative. Well, what does that mean? That's where the expression is negative. If you choose any number from -infinity to -4 and run it through, it'll make that expression negative. If you choose any number between -1 to 3 and run it through, it'll also make it negative. And then any number from 3 to 5 will make that negative as well. So that's what it means. Now, where is the expression equal to 0? Because this is all this greater than or less than. It'd be equal to 0 for any values where the numerator was 0. Well, what about the denominator? Remember, we got some key points from the denominator, but can a denominator be 0? No. So any key point that came from the denominator tells us where it's undefined. So in grade 11, we just learned how to use it, and then in I'm looking ahead 2 years. If you go to calculus, like right now, the calculus class, they're in the curve sketching unit right now. They're making a whole bunch of sign diagrams and eventually putting that together to make a graph. But in grade 11, we just need to learn how to use it and interpret it, and then you'll get to use it in calculus. Okay, good luck, have fun. This is a new concept, but it's a big one, especially if you're going to go to calculus in the future. Okay, good luck.